Hi, I'm Karl McGuinness. I'm the Chief Product Architect at Okta. I'm here today to talk about continuous auth, rethinking the enterprise IDP. For a lot of us, the foundation for our access control model is still the network. It's a pretty simple model. It's nice that we have a single way to do revocation. You kill the network, the user doesn't have access to the resource. And this has been the primary way we've done access management for many, many, many years. And around 2009, some early thinking from folks started to think about a better way to manage access via the network. And so it became popular to start thinking through more of a software-defined way to micro-segment your networks so that we could start blocking more of the lateral attack mechanisms that we started to see in our networks. And in the last decade, the rise of mobile cloud computing has sort of moved the resources outside of our perimeter and into the internet, where they've been accessible by not just our employees, but our contractors, partners, and customers. And so the traditional network architecture access control model has been completely dissolved. And so we're now at a point in time where the people are the perimeter of our network, with BYOD accessing anywhere from an internet cafe to your home, to any user from a customer or partner accessing your resources. And so around 2015, sort of best thinking started to evolve around Google's Beyond Court model to crystallize this movement to people as the perimeter, where we start thinking that our internal networks are the same as our external networks. So today, the landscape is that identity is now the foundation for modern security. And so what we want to be able to do is grant the right people the right level of access to the right resources in the right context, and it's accessed continuously with the least friction possible. So let's take a look at how this might look in your traditional or your modern enterprise today. So a modern enterprise would have at the center of their access control model now the identity provider that connects to their applications through federation technologies like SAML and OpenID Connect, and then does user management and provisioning through a protocol like SCIM to provision access into those applications and revoke access into those applications. Your users and devices would be connected to your enterprise IDP, and you would have a central control plane in your enterprise to grant and revoke access to those applications. And connected to your enterprise IDP would be your HR system, so that you can directly feed who is an employee, your employer lifecycle, your employee lifecycle management, joiner, mover, leaver, directly to the identity provider, so you can have a consistent view of access. Now, increasingly, your enterprise IDP is also playing the role of maybe a radius server and also becoming an authentication authority for your network access equipment, so that you have it brought in the control plane for your networking gear in with your federated identity control plane. But there's also now your devices. And so connected to your enterprise IDP is your unified endpoint management software and your endpoint protection platform software that's monitoring your devices and your device health and connecting that into the identity provider to make sure that you have trusted devices accessing your resources. And then finally, you're feeding a lot of the activity data into a centralized monitoring system that you're able to build workflows and automation on to do remediation to revoke access based on security incidents and risks that then is connected back to your enterprise identity provider. And this provides a lot of the core primitives in your modern identity access management strategies. And then finally, you may have additional requirements to manage session level access to resources. Maybe SAML and OpenID Connect are great technologies to provide single sign-on, but you might need to have additional session level controls and leveraging a technology like CASB, which is disintermediating a lot of the flow between the end user and the resource, similar to what we saw in the past with traditional network-based architectures. But access is increasingly a layer 7 problem. We're moving from sort of a connect first and then authorize second to an authorize first, connect second model, where the decision on who can access what is going to be based on context. So it's user, the authentication assurance of the user, the device security posture, the time of day, a lot of other dynamic runtime variables are determining whether the user has access to the resource. The user isn't just statically granted access to the resource. And it's the context in this that's changed a lot over the years, that we're increasingly trying to increase the amount of context we have to make the decision of who has access to the resource. And adding a device into the equation has been significant in addressing some of the BYOD concerns, because now it's not just, does the user have strong authentication, MFA, to access a particular resource, but is the user on a secure device? Which brings us to assurance. So assurance is, how sure am I that you are who you say you are? And assurance decreases over time. So you log into a computer once early in the morning, the computer screensaver may be unlocked. As you proceed throughout the day, that assurance of that original authentication event decreases. You're not necessarily the same user behind the same keyboard 20 minutes, an hour, 2 hours later. Similar, if we send an out-of-band push notification, it may not be you sitting next to that phone after that original authentication event. And our attributes that we're using to make contextual-based access control decisions attenuate. The quality of the data is not consistent over the life of the attribute. So if you just take a look at your driver's license today, there's a good chance that the photo, the address, your weight, your height may not be exactly what it says on your driver's license. Probably the only thing that may be consistent is the birth date. And so a lot of times we're making decisions in our access control planes based on attributes that have decayed over time and may not necessarily be the most accurate. And so when we think about access isn't static, it's an ephemeral quality. Things change over time. And so in going back to our modern enterprise IDP, when we look at some of the things that happen in the enterprise that may change access, it could be starting from the HR. Obviously, some of the core user attributes may change. Maybe they've changed of address, maybe they change a title, which then changes the set of entitlements of what they should or should not have access to, or even more importantly, the user's terminated and they shouldn't have access to anything. Those changes may then represent themselves as a certain set of policies that are assigned in the IDP that need to be applied to the different resources. From the user or device perspective, maybe the user is logged on to their device. Maybe a different user has come in and unlocked and locked the device. Devices roam. We talk a lot about mobile devices, IP addresses, cell towers. The device's IP address information is not static. And if you're doing network-based access control, that needs to get reevaluated to determine if they should or shouldn't have access. Obviously, the device posture changes. You install software, malware can be on the device software patching can be out of date. These are types of things that maybe your endpoint protection platform or endpoint management software is able to detect. Configuration drifts. So ultimately, this gets to the point that risk changes. It's not static, and access isn't static. And our enterprise identity management platform needs to start thinking about how to deal with a world where access isn't static. So how does that look today with traditional SSO technologies? So in a traditional SSO deployment, federation only provides access control during the original sign-in event. So when the application redirects to the identity provider can use that device context, the user assurance context, the network IP, potentially have an integration with a threat detection system, and determine, hey, should this user be able to access this particular application? If the IDP needs to force the user to re-authenticate again, it's limited to a technology such as single sign-out, which has varying degrees of deployment in the industry, primarily because it's a best effort protocol. There's no real guarantees that single logout has actually happened. So to address some of these shortcomings, what is common practice is to sort of create an application session lifetime that's much shorter than sort of the identity provider lifetime session, so that the application redirects the end user back to the IDP to force a check again. And so you get this sort of loop where, say, every hour or every day, the application kicks the user back to the identity provider to giving the identity provider a chance to reevaluate policy again. But keep in mind that the IDP often has very limited context from the device and technologies on the platform to be able to make an assurance level check. And so what ends up happening a lot of times is the user is forced to do full two-factor authentication every time they need to revalidate their assurance. And this leads to a very frustrating experience for our end users where they every day are being asked, hey, why do I have to keep logging in again? And that's just a constraint of both the identity provider having limited context and the application not being able to update whether you should have access or not without kicking you back to the identity provider. So where do we want to go? We want to move to more of a continuous access evaluation model where the access is not static, but more continuously evaluated. So it starts with authentication. So leveraging modern technologies, we want to be able to more passively authenticate the user and do that more often to try to increase that assurance level so it's not a point-in-time snapshot. We don't want to ask the user to enter their password every hour or so, or potentially enter an OTP. We want to be able to leverage, for example, the geolocation, the paired Bluetooth devices, maybe something like Face ID, maybe a connected heartbeat. There's a lot of different ways we could try to increase that signal by making sure that you, the human, are still there. And that's a concept we call continuous authentication. And continuous authentication is powered by a big investment in standards around the FIDO Alliance and WebAuthn that sort of opens up an ecosystem of authenticators. The core principle is that the authenticator itself stores a cryptographic secret in hardware. That cryptographic secret is a public-private key pair. The public key is stored on the authentication server that you can use to verify the authenticator. And then the authenticator releases that key material via a user presence test or a user verification, such as a biometric, a voice print. And so what you see here is a decoupling between the ability for the authenticator to prove to the server that it's still the authenticator, but then having a way to verify the human on the other side using an ecosystem of technologies, all best of breed, connected into these different hardware platforms, creating the ability to do continuous authentication all over web browser technology. But it's not just user authentication that we need to consider. It's also how do we do continuous device security posture? So as we mentioned, device security posture changes over time as well. So I may download some malware and start running it on a particular device. And in a managed deployment, we can address some of these concerns by tightly integrating the endpoint protection platform, the unified endpoint management software, and your security information event monitoring into the IDP to revoke access for devices that are no longer compliant. And so if we have a strong signal from these systems that the device compliance security posture is still valid, we can keep access for the given user for their given set of sessions. But for BYOD systems, there's obviously a set of challenges. You don't always have the same set of management technologies. And so a lot of times enterprises are dealing with non-uniform a set of technologies and need to try to provide ways to address some of this. And this has been an area that Okta has made a lot of investments in. And at Octane 2020 this year, you're going to hear a lot of us talk about Okta FastPass as a technology to help address continuous device security posture assessment for deployments where BYD are managed, where we can augment some of the existing set of signals that you may already be integrating into Okta, and especially for BYOD systems. But at the root of this is if we have continuous authentication and a long-term secret that you're using to access a set of resources, how do we manage changes to that session over time? And so back to that single login problem, sessions create a challenge. How do we attenuate or change what a session has access to? How do we revoke it or refresh attributes about that session in a distributed system? And this has been sort of a significant challenge over the years of identity architectures. And this has gotten more complicated by the change in use cases and client types. We're no longer just dealing with a deployment model of just sort of browser-based applications where we have sort of web management technologies and cookies that we can use to try to address some of these challenges. We're starting to see a much wider range of client types. We have native applications running on mobile software. We have command line tools, maybe accessing our servers and IaaS resources. We have stuff in the cloud. We may have some IoT and other smart devices that may be accessing our resources. And sort of modern applications are native applications. And with native applications, it moves to a model of sort of continuously or reprompting the user to authenticate to sort of more of sign in once. And so an application like Slack, for example, an end user may only authenticate once the first time they've downloaded it, and the application just sits there and runs in the background and is continuously accessing corporate data and sharing corporate data without ever asking the user to log in again. And these applications are also platforms in and of themselves. It's not just the individual application that the user is accessing, but they may go and authorize an ecosystem of tools to connect to these services. Each one of these, their own platforms, their own applications, and there's no central sort of session cookie or session management to be able to force the user to reauthenticate when we start thinking about these things as application ecosystems. And so a lot of times these modern applications are built on a new technology that is OAuth 2, which is more of a token-based model. So we were really familiar with federation technologies like SAML and OpenID Connect that operate in the browser. They redirect the user to the IDP, you get an assertion, and you may sign in to an application and have a web session. But after that web session is established, you get sort of OAuth 2 tokens that are used to access APIs, and APIs can access other APIs. And so our modern access management strategies have to start thinking about not just web sessions, but OAuth 2 tokens. And OAuth 2 has a concept called a refresh token, which is a pretty powerful concept that makes it power native applications so that native applications can request new tokens in the background to access APIs without having to prompt the user to log back in again. And it's this refresh token that creates a new set of security challenges. And so when a native application like Slack tries to hit its backend APIs to get some new messages or download some data, it has a token that it uses to do that with. It's authorized to have access. That token can expire and can go back to the central authorization server for Slack, get a new set of tokens all in the background without having to ask the user again. So let's walk through an end-to-end scenario here of how this plays out for a modern IDP. So we have our end user in a browser on a device running an application. That application is connected to its backend. Its backend has both an API that powers the app, as well as an OAuth 2 server that's issuing tokens to access those APIs in your enterprise IDP. So the end user starts the flow, launches the application. The application doesn't have an existing session or tokens, and so it connects to its backend saying, hey, I want to start to request tokens. Now, the user does this in a browser flow now, saying, hey, I need to authenticate the user with your enterprise IDP. So the authorization server is going to do a redirect for the user to their IDP in a traditional federated single sign-on flow. So now the user is being challenged for authentication. We're going to authenticate with the IDP. Maybe we have step-up authentication based on the policy provided by the identity provider. Maybe we have an integration with endpoint management software where we're able to detect the presence of a certificate for the device, determine that, hey, maybe it's a trusted device, be able to verify attributes of that device that's using the identifier from the certificate to verify the health of the device. And so we can make our contextual access decision here that this user on this app is able to access, so we can give it an OK, issue it an assertion, and log into that authorization server. So we now have a session on the identity provider. We now send that assertion over, and we create a session on the authorization server. And now the web browser flow part of the thing is complete. We issue it some tokens that it can use to access the APIs in the background. And the app goes off and continues to use those tokens to access the resources that it needs. So everything's in a healthy, green, steady state. Things are fine. App's accessing its resources. User doesn't have to see a login prompt again. But maybe something changes with security posture. Maybe security posture changes on the device. Maybe a policy change happens, or entitlement or lifecycle state changes for the user at the IDP. What happens to those tokens that the application has to access the API? Well, in today's world, not much. The app can continue to operate as needed. There's no clean way to force that application to check back. And so we have a security risk here. And then finally, these APIs, like as I mentioned before, from these SaaS platforms, may not even being directly accessed by a client that the end user is interacting with. Maybe it's a connected third-party service that's connecting back in on the back end and is able to request tokens and access that API. And it's not even checking back with the enterprise IDP to see if it should have access. So let's look at some of the challenges. So the first is the enterprise IDP is not the one that's making the decisions for the tokens, the OAuth authorization server. They're sort of separate entities. The IDP only gets invoked during the SSO browser redirect, which, depending on native applications, may only happen once for the native application. And then because the IDP is operating in a web context, it's limited to what can be established through a web context. It may not know much about the device that's calling it. It may not know what native application is calling from it. It just knows that it sees a browser that's being redirected. It may not know that it's the Slack native app that's launched the browser that's redirecting to the IDP. And then the SaaS application on the other side doesn't know anything that the IDP knows about the device or context. It just knows about the identity assertion that comes back from single sign-on. So it just knows, hey, I'm user Karl from the enterprise. I've been issued access to this application. It's been signed by the enterprise. I'm good to go. But maybe on unmanaged devices, I don't want to allow download of file data in Slack, as an example. It doesn't have the ability to do that if it's just looking at identity claims. The enterprise IDP policy that's defined was only evaluated SSO. So if there's a change in policy that needs to do revocation, there's not a clear way for the IDP to do revocation. It can try to do a single logout, but that may only happen in the user browser session and can't happen retroactively in the backend. So for example, a feed from the HR system or a feed from a threat intelligence system or from the EMM or device posture change doesn't have a clear way to tell those applications to check back in with the IDP. And coming back to the core issue, risk can change after the session is established. The session itself isn't permanent. It's something that it can change over time from a risk perspective. And then finally, the SaaS platforms are connected platforms, and we have to start thinking about the access from those connections that may not be from the end users directly. The core principles of access, right? We have the core authorization model of policy decision point, policy information point, policy enforcement points. Today, these are centralized usually in our architectures, like in a web access management technology. We sort of have an end-to-end system to do both policy enforcement and decision and administration. As we think about a cloud-first world and the resources are moving more and more outside the perimeter, it's becoming increasingly challenging to have a consistent architecture for both policy decision, evaluation, and administration, especially when we think about the internet scale problems of centralized and decentralized models. We can't have every single transaction check back to a centralized source for everything that we do. We have to enable decisions to be more decentralized and cached for periods of time in order to handle the internet scale traffic and use cases. So let's look at the opportunities we have to evaluate access in a life cycle. So the first one we've talked most about is sign-in. That's where the IDP does most of its access control today. And that is a fairly decent coarse-grained control model for a decision that should last for hours to days from a security perspective. Sort of going down the stack, the next level of opportunities is the ability to reevaluate access when one of those OAuth tokens are refreshed or when a session is evaluated. These are opportunities that are really more at the minutes to hours level to do access revocation or evaluation checks in our systems. Then through being able to monitor data and inspect data and analyze data and connect to third-party data systems, we have the ability to out-of-band respond to access changes and push changes to downstream systems. And this gets more into the curve of being able to respond in more real time. And finally, the ideal state would be to authenticate and authorize at the transaction level. We move from sort of long-lived sessions or tokens to the individual transactions themselves being real-time authenticated and authorized. Now, from a performance and scale perspective, that may not be possible to do for every transaction, but maybe high-value transactions, we want to move the authentication and authorization model to a transactional kind of level to do it more in a real-time ability. But addressing these access opportunities, we can't do them in a proprietary way. Customers want a best of breed. We're no longer in a world of a few set of technology providers and vertically integrated platforms addressing the end-to-end technology platform needs. We've moved to a world where software is eating the world. Everybody is a technology provider. And we're seeing a wide range set of best of breed technologies from the devices and platforms. It's no longer sort of a single platform. We have a lot of differences happening on both mobile and desktop, to the types of users and BYOD, and the best of breed applications themselves. How do we get a best of breed approach to some of these challenges where we can't just dictate sort of it works well on our platform? How do we make it work with the technologies of your choice? So I want to talk about sort of 4 key challenges for best of breed for continuous access. The first one is device identity and security posture. Device identity and security posture is challenging because browsers themselves don't provide a native way to address device identity and security posture. In fact, it kind of goes against the grain. Browsers are increasingly trying to protect end users from a privacy ad tracking perspective. The ability to know which machine you're on from a browser perspective is getting harder and harder to do. And the authentication technologies to date, and even modern ones like a lot of the FIDO and WebAuthn, are designed for user-based authentication technologies, leaving sort of certificates and some other approaches to be how folks have to address device level authentication today. And as I mentioned in the original flow, the native application first starts the flow talking to its backend, and that's where the native application can ask questions about the device itself, where before it determines that it needs to launch a browser to log into the identity provider. And so, unfortunately, today, there's really no way for that flow to pass the context that was established when the native app bootstrapped to the identity provider, so the identity provider can make a more contextual-based decision. And so there's been some early thinking about potential ways to be able to pass some of these device posture signals. So maybe the identity provider would like to know what version of the operating system's installed. Does the device have encryption enabled? Is there a PIN code enabled on the device? What's the name of the application and version of the application software itself? These are attributes that you don't get over the browser flow that single sign-on is typically doing. And so in order to sort of move the maturity model forward, the ecosystem might need to adopt a standard to be able to establish this context and pass this context on top of these OAuth flows and sort of integrate with the identity provider flow to be able to establish end-to-end context between the user, their device, their backend, and the enterprise identity provider. And once the identity provider has done device-based access and has the integrations into backends like endpoint or enterprise endpoint management software, it needs to be able to pass that back to the service provider about the assurance of the device. We have a lot of standards now to determine and express authentication assurance claims for a user. We can tell a service provider that the user authenticated with a non-phishable hardware-backed authenticator, which is a pretty high degree of assurance that the user is who they say they are, because it's a very hard-to-phish authenticator. And so that gives the service provider a high degree of confidence that the user authenticated very strong. But we don't have a way to say the same thing about devices. And so there's some existing standards in NIST and RFC for vectors of trust that give frameworks on ways to talk about authentication attributes that might need to be extended in the industry in order for us to be able to pass these assurance claims and have interoperability between the identity provider and the service provider. And Okta today has done some early steps working with some partners with our limited access feature and our VMware feature integrations to start exploring some of these claims that we can pass to light up some of these scenarios. So we talked about a little bit about some of the challenges of getting device context and device security posture across that boundary between the service provider and the identity provider. Now I want to talk a little bit about how the identity provider and the service provider can talk about sessions and tokens and potentially change their lifetime or revoke or change their attributes while they're active. So the first one is really out of band. So today we do a lot of out-of-band provisioning and lifecycle management for our user accounts. So using a protocol like SCIM, an identity provider can out-of-band deactivate a user when they get terminated in HR. And deactivating that user in the SaaS application more than likely will terminate all their existing sessions, and the user shouldn't have access to any resources inside of the SaaS application. But that's a pretty heavyweight solution for more risk-based authentication scenarios. A termination is a pretty strong signal, and the result is pretty uniformly don't access anything. But maybe there's some scenarios where risk has changed, where you just want to change a bit of the access. Maybe you just want to re-auth the user. Maybe you just want to recheck the device. Maybe you want to turn the application from write mode to read mode, as an example. So in order to do that through an out-of-band mechanism, we would need some set of API surface area that the SaaS application exposes to manage some of those primitives that are needed from an access perspective. So from an OAuth perspective, a lot of the standardized protocols for OAuth are just detailing the interactions between the application and the backend. It doesn't really detail a lot of management protocols to manage a set of OAuth servers. And this is actually a pretty a modern problem statement, because it wasn't too long ago that a given enterprise may only have a few of these. But in today's world, where most applications are moving to SaaS-based offerings with platforms, a given enterprise may end up needing to manage hundreds to thousands of OAuth authorization servers, and this isn't practical to do on a manual basis. And so there's an opportunity to define a standard set of API surface area here in order to manage what applications can access, what permissions can those applications get for specific users, be able to revoke tokens that have been issued by those authorization servers that may then force the end user to go back to the identity provider or reevaluate context, or even the ability to update the context directly itself to make access decisions. Going from the authorization server, the next layer would obviously be the ability to manage sessions, right? So we can sort of use a coarse-grained trigger like SCIM to revoke access for everything, but we may want to revoke a particular session or update context for a particular session, because a user may be signed into multiple devices. They may have multiple active sessions. And so if we want to deliver the best experience for our end users, that coarse-grained kill all across all contexts, across all devices, just because we've noticed a slight change in risk, may be creating more user friction. And we'd ideally want to target it more towards the device they're on, or a particular application or a particular session. And then finally, rounding out the API surface area would be similar with devices, and the ability to obtain all of the data about activity from that user inside the SaaS application, so we can better understand how the user is accessing the resources in the application. And today, every one of these APIs is not a standard API, and it's up to the vendor themselves to determine should they implement any of these APIs and what they look like, creating a very hard to orchestrate scalable solution for enterprise identity providers. This is also an opportunity that Okta is looking at with a new technology that we've announced at Oktane 2020 with the Okta Workflows. Okta Workflows today is starting to address lifecycle management use cases, but we anticipate in the future the ability to use Okta Workflows to integrate with API surface area around vendors to address some of these concerns. We mentioned earlier that with modern applications, they have offline access refresh tokens, which they can use to access resources when the user isn't necessarily at the keyboard. Well, one of the needs going forward is more to not just have an offline access where the application is completely decoupled from the IDP, but what we'd like to get to is some sort of ability to correlate the concept of a session between the IDP and the authorization server. So when the user signs in with the identity provider on a device, we would like to bind a session for that user to that device and somehow identify that to the authorization server so that there's a concept of a shared handle or a way to identify that session between the identity provider and the authorization server. And then when tokens get refreshed from that application to that backend, it can ask questions about that session handle and say, is this session handle still valid? And maybe if need be, the authorization server can check back with the identity provider in the backend to see if anything's changed and reevaluate policy without necessarily triggering a single logout, popping the user to a browser flow. So the idea here is give the application the ability to have a handle that it can use to go check and do policy reevaluation back with the identity provider all in the back end, and be able to integrate that into an application experience where we can do this more regularly outside of SSO and increase that assurance level without triggering a bad negative user experience. And so there's definitely some details here to sort out. But the idea here is to be able to sort of evolve our core OAuth and protocols to be able to support such a use case. So we have ability to identify the devices. We have the ability to have API surface area to revoke sessions about them. And now we have established this identifier that's linking sessions between applications and the identity provider. Now I want to talk about the next level of problem statement, which is managing controls for a given session. So session controls tend to need to get mapped to responses to how they should behave for a particular application. So maybe a change in session risk should make an application read-only. Maybe I shouldn't be able to download individual files inside the application. There needs to be this mapping between what is the risk that changed to what's the appropriate security control I want to enforce in the application. And since every application has a different set of security controls they enforce, this creates a challenging scalability problem of how to create a mapping between the different changes in risk to responses in the applications. So one of the ways we could potentially scale this problem is by having a way to enumerate the different session controls that are available in a given application. So maybe an application can publish a policy, which is the ability to have, for example, a read-only security control, or a managed device security control, or a guest computer security control policy that then inside the SaaS application defines what that may actually do to the individual resources, because again, the resources vary across applications. But then there's a way to identify that the identity provider can call out and say, I want to apply, for example, the managed device policy. And so using contextual access management that we've been talking about, the identity provider could assert that and pass that through the assertion during single sign-on. It could pass that through an out-of-band provisioning or API call if there's a change in detection saying, hey, switch from the full trust security policy now to a minimum security policy while the session's been active. So the app provides and owns its policies. The IDP can leverage this to map to it, and we can pass them through assertions and APIs. And so if we can move this from something that's a per vendor modeling to more of a standard approach of being able to identify and apply these at runtime, we can address more of those runtime session evaluation problem statements. Excellent. So the final thing I want to talk about is shared signals and events. Shared signals is the ability for the identity provider or the service provider to publish an event that the other can subscribe to. And so often an identity provider knows security risk before a service provider has a chance to respond to it. So the identity provider knows, for example, credential theft, credential stuffing, broad-based credential attacks that may happen. Maybe on one tenant, we saw a bad actor try to brute force a set of credentials, and we're able to block that actor in another way. We're able to see how users are doing account recovery, maybe trying to exploit a chain in the account recovery chain. And it would be useful to be able to publish that to a service provider, because maybe that changes the risk. Maybe the ability to have that application that's always logged in may want to force the user to log back in again if the identity provider was just able to tell them that there was a significant security event that just happened at the identity provider, like enrolling or changing my security credentials. And so sharing the visibility of these key events would enable more of a dynamic response from the service provider. So we could think of many categories of events, everything from traditional lifecycle events, authenticator events, assurance events, session level attributes or token revocation events. Would be powerful for the identity provider to share those and allow the service provider to respond to those. And vice versa, the service provider may know things that the identity provider doesn't. So let's use an IP as an example. If you have an IP restriction policy where you only want certain users on certain network segments to access an application, the identity provider could traditionally only enforce that at SSO time, but then the user establishes a session with the application, closes their laptop, goes home, opens up their laptop, and they're still logged into the service provider and their IP address has changed. Maybe that new IP address, though, violates policy. How would that work in today's world would be quite challenging. But if there was an ability for the service provider who knows the new IP address because it's getting the client connection to publish that back to the identity provider, the identity provider maybe could reevaluate policy and then use one of those, for example, out-of-band orchestration mechanisms to take a remediation action. So shared signals and events is really the ability to do publish and subscribe of security events, whether they're both about the account and security level or just domain level events that are useful for managing access over time. So let's walk through a security example of how shared signals plays out. So I have my identity provider, an application, and a connected application. So in this example, Box is connected to Slack to share files on Slack. So my identity provider, a user starts the application, signs into the identity provider issues an assertion to the application launches, the user then authorizes a connected application to sign in so I can access resources on those particular applications. Then an attacker goes to the identity provider in this example, tries to initiate an account recovery flow, and tries to attack the account recovery flow. Maybe they were able to port my SIM card over from my phone to their phone by exploiting the telco provider as a way to try to get a password reset to go to my device. And so the identity provider notices that there's been an account recovery operation that happened. It can then detect that change and broadcast that back out to the application that was previously signed in as a signal. That application then can say, hey, this creates a higher security risk for this already active session. I'm going to want to respond to it. And so it can then be able to broadcast that to its applications that it's connected to as well. And so you have an end-to-end scenario here where all the applications can respond out of band to a change in security that happened because something was first noticed upstream in the identity provider. And so the idea of shared signals is that it enables an ecosystem to solve a very challenging problem set. And so a lot of thinking has been started in this area around continuous access evaluation around shared signals. It started with a protocol called CAPE, Continuous Access Evaluation Protocol, that now has moved into the OpenID Foundation as part of the Shared Signals and Events Working Group to try to define the standard for how these shared signals should work in the enterprise. And the idea is that identity providers, endpoint security management providers, networking device and equipment providers, CASBs, threat intelligence providers can all build an ecosystem around publishing and sharing these events to provide continuous access evaluation. And that gives us to sort of the end state of the enterprise IDP being a signal hub. So if we connect all of these back-end best-of-breed integrations of how your enterprises are using security technologies to improve security outcomes and reduce user friction from both endpoint management software, networking equipment, security, information event management software, all sharing signals to the IDP connected and sharing signals with SaaS applications, the IDP itself, for applications you build, connecting with lower level things like the API gateways and services that you're building, to be able to create a hub that can broadcast and share these signals across your enterprise, creating a consistent access control plane for your entire enterprise. And that's the end vision statement of an architecture that is enabled by shared signals. leading us to ultimately a real-time identity intelligence solution, right? We don't want to be able to have to deal with humans to respond to internet scale problem statements. The attack surface area is increasingly getting larger. The number of resources are getting larger. The types of devices and access and personas are getting larger. Everything is just exponentially increasing. And in order to address the surface area of that problem statement, we're going to need more automated systems to detect and respond at this level. And a shared signal architecture helps us make progress on that goal. And finally, where is Okta headed? Our roadmap today is focused initially on sort of improving that continuous authentication, providing adaptive risk-based authentication to increase assurance of the user over time. We've launched at Octane 2020 our device identity platform, Okta FastPass, the ability to integrate device context into authentication and access control decisions and be able to deploy that across managed or BYD profiles. We've launched our Okta Workflows product that gives us the ability to orchestrate events and activities across an ecosystem of APIs, such as being able to revoke access. We've launched Okta Limited Access, which is the ability to pass device claims and device posture inside of federation assertions. And so these are all sort of current roadmap capabilities that we're currently investing in to improve our continuous access story. And then finally, we're participating in the industry long-term initiative to build that internet scale pub sub protocol that's really going to move the needle on continuous and access. And so that's the future of the enterprise IDP. Thank you guys for listening. And if we have any time, we'll take any questions.